Right, so I'm going to talk a bit today about building evolutionary infrastructure using pipelines. We'll talk a little bit about what that means. But just around kind of my background, how I came to be talking about this stuff, I guess. I've been working in the industry for a bit more than 20 years now. And I've always worked across kind of development teams and operations teams. I kind of like went back and forth in the early days. Whenever I worked in a development role, I was always interested in how can we automate the way our software is deployed into environments and all that kind of thing. And whenever I worked on the operations side, I was always interested in how can we kind of script the way that our infrastructure is configured and built and that kind of thing. And then it was probably around, I think around 2006 that the terms DevOps and infrastructure as code kind of emerged. That was really cool because it kind of legitimized, I guess, a lot of things that I was interested in. And so I kind of like follow stuff and learn stuff. And then I joined ThoughtWorks about 8 years ago now. And so ThoughtWorks, we basically help companies delivering software and how they deliver software. And it's kind of traditionally come from the kind of agile and continuous delivery as well. When I joined was the book was coming out from a couple of ThoughtWorkers. And so my kind of role was, okay, we're coming in with software delivery teams. In order to do continuous delivery, we need to be getting into production. And how do we do that? How can we kind of make that work well? And so I found myself working a lot with infrastructure teams and operations teams on adopting these kind of infrastructure as code ways of working. And so eventually I ended up writing the book just to kind of like share these ideas that I learned and heard from other people. It's not necessarily stuff that kind of like I came up with. It's more like stuff that I learned and wanted to share. And then, and I think interestingly, the infrastructure side of things has become more and more to the forefront. There's a lot more people in the operations and infrastructure world interested in learning about how can we do this stuff better. So very recently, another book's come out from a few colleagues and a former colleague of mine on building evolutionary architectures. And I felt like this is like a really important thing. I've been kind of waiting for this because I think the mentality that we've often had in the industry is that we do change in big bangs, right? So we kind of like have our systems and we kind of like we fiddle with it a little bit and kind of keep it running. And then we can always go to the whiteboard and draw our current system and everything that we hate about it, right? Everything that's wrong with it. And so we always like focus on, we're gonna have then we go to the whiteboard and draw like, this is what it could be like. And it becomes like this big kind of gap in a big massive project or program of work in order to get from one to the other. And then you always end up taking shortcuts and stuff in between. You get time, pressure on time and all that kind of stuff. And you have to take shortcuts and you learn stuff and figure out your original ideas. You kind of miss things or you didn't understand. Let's say you're moving to Kubernetes, and so you plan it out before you actually know how it works, and then you start doing it and you learn all the lessons that some of the lessons that we've got were shared with us earlier today, the hard way, right? And so the idea of actually let's make changes kind of bit by bit and make change is the normal way of doing things. Small changes as rapidly and continuously. And so rather than seeing change as something to be kind of like managed and resisted and controlled, change is something that we harness to our advantage, so to make continuous improvement to our systems. Another good book, and I'm not sure how many people here are familiar with the State of the DevOps report. I asked this in the panel, but okay. Only a few people. It's just interesting because so the State of the DevOps report comes out every year, and they survey organizations in IT and about the practices that they're using. So a lot of the stuff that we talk about in Agile and DevOps and Lean and all these kind of things, they survey like how companies are actually working. Are they using pairing? Are they using kind of branching versus trunk-based development, continuous integration? And then they correlate these, and this is all like very kind of like done academically, statistically, so it's like really solid stuff. They correlate these to the performance of the organization in terms of how often do releases fail and have to be rolled back? How much time is spent on remediation work, fixing things as opposed to building things? As well as organizational characteristics like revenue and share price and all this. So they correlate all these things. And one of the things they found is that whereas traditionally I think we have this idea that you have to trade quality for speed. It's like one or the other. You either go fast or you take your time and you have good quality. What they found is actually that's not the case. Actually, the high-performing organizations do both. They move faster and they have higher quality, more success, spend more time building new features. And I think it's because you have to be able to move fast in order to improve the quality of your system. If you can't move fast, you can't fix things. And so you kind of tolerate low levels of quality. If it's going to take you a long time to fix something because you have to go through a heavyweight quality process, you don't fix it. You put it on the list of known issues and just kind of like, yeah, that's just the way things are. We wish we had time to fix it, but we know we don't. And this book is by the same authors who run this State of the DevOps report. They capture a lot of that in this book. And so if you're having these conversations with leaders in your company, in your organization, around whether to adopt these practices, and especially if they're the types, so I want evidence, I don't want this kind of hippie, everybody be nice to each other stuff, I want kind of, ironclad stuff. This is really good material to kind of back up those kind of conversations. Right, so if we're going to be able to evolve our infrastructure and not have it, changes only in big bangs, what are the kind of requirements? And I have two, main areas that I want to kind of think about and address. So one is the capability to deliver changes. And so this is where we talk about the pipeline and those kind of things, and testing, automated testing, and all these kind of things are things which enable you to move quickly with confidence. It also includes stuff which I'm not going to go into as much in this talk around your process and culture and all those kind of things. So you need to have this kind of attitude and have the pieces in place that you're physically able to make changes quickly. Another thing is that your architecture needs to be easy to change. So if you have a big ball of mud, spaghetti architecture, monolith, what have you, you can't really just add automation to it, add some automated tests, add some automated deployment, and then you're going to move quickly. It doesn't work that way. You have to kind of re-architect and break things down in order to enable those things to be able to change quickly. And so I'll talk a little bit about some patterns around that as well, for infrastructure in particular. Right, so one of the things in the Evolutionary Architectures book they talk about is this quantum, an architectural quantum. And what they're talking about there, they're talking overall in system architecture around what is the kind of smallest unit that you can kind of deploy, a meaningful unit of change. And obviously, there's the monolith. If your architecture is a monolith, that's your quantum, right? You can only deploy the whole big thing. If you go to microservices and you have very small quantums, they also talk in the book around other kind of architectural patterns, things like kind of microkernel and plugins and these kind of things. So it's more than just monoliths are bad, microservices is good. There's more kind of variations to think about there. So in terms of infrastructure, and infrastructure as code, the quantum that I like to talk about is the stack. So an infrastructure stack is basically a collection of infrastructure that you kind of change and deploy as a unit. So how many folks here work with Terraform or are familiar with Terraform? A fair number. What about CloudFormation? Okay. What about any other similar tools in that category, tools that you use to automate? So this is around like automating. So it's like, it might be a group of servers, networking around it, storage that you allocate, and all to that. And Terraform, it's like a project, right? Something that is associated with a state file. In CloudFormation, they actually literally call it a stack. That's the term that they use. And so the most of what I'm talking about, the patterns that I'm talking about today, are kind of at this level as opposed to at the level of things at the kind of chef and puppet level where you're configuring packages on a server. So that's kind of a sub, kind of a smaller unit, I guess, although I will touch on that a bit. So when I think about stacks, I have two kind of things. One is the definition, right? And that's basically the source code, right? This is the thing that defines what does my application's infrastructure look like. Okay, I need a auto-scaling pool of servers with a load balancer, maybe some kind of security groups that define ports that go in, and maybe storage volumes get attached to things, database maybe. So it's like, here's the stuff in my application, and this is the Terraform project or the CloudFormation project or Ansible, whatever. The tool doesn't really matter. It's the code that's going to define this thing. And then you can have multiple stack instances that you create from this definition. And this is an important concept that we'll get onto. So you might have different reasons why you have one stack definition, one set of source code, one project that you use to create multiple instances. And one is, as I'll get into, kind of environments, right? We're going to say, okay, I'm going to deploy this to QA and staging and production and so on. Another is you might use it for different roles. So you might have, let's say, a stack that creates a database cluster, and then you say, okay, I'm going to create different database clusters for different applications that have maybe different kind of variations between them. So the multiple environments one is the kind of useful thing in terms of what I'm talking about today. And this is the idea, okay, we start out with our infrastructure project, and we've got maybe a simple project, 1 or 2 people working on it, and we have our let's say, Terraform project. I use Terraform as the example often, but again, the tool doesn't particularly matter. So you've got this Terraform project, and you've got your environment, and all's well and good. But then as time goes on, and you get more people working on it, and the stakes are higher, so you're going from kind of that startup where nobody's really kind of paying attention to what you're doing to where you have users who care if your system goes down, if you break something. And so you need to kind of move beyond that. Just we've got our one environment, right? And so obviously you want to do the traditional thing. You've got whatever you want environments you need to have in order to kind of progress your changes, to work on changes and test them and get them through into production. Whatever they are, you're going to have a few different environments probably. And so the first approach that people tend to take with this kind of thing is you say, okay, I'm going to have my Terraform project, and I'm going to have within this project, each of my environments. So here's some files here that are my test environment, and then these ones define my QA, my production. And then I can make changes to one part of it, and then I apply it, and it changes that environment, make changes in the other, and apply it, copy them from one to the other. I don't know if, so Charity, who's going to be talking after me, wrote a good blog post a couple of years ago where she was going through this kind of pain. And it really, I think, brought this kind of to the forefront of conversation and the kind of, I guess, sphere of talking about infrastructure and DevOps. And she used the term blast radius, which has really caught on, and I hear it used all the time now. And the point here is that if you've got a single infrastructure project and a single stack, and you make changes to one part of it, you can easily break another part of it, even if you don't intend to. So you say, I'm going to make a change to the test environment, you change this bit of code. And then for some reason or another, whether it's because maybe there was some other part of the code that you changed or forgot that affected production, or maybe the change you made is something that's actually shared across environments and you didn't quite realize it because it's getting kind of bigger and more complicated, but you end up breaking something else because of that. And so this is where you want to move on to the idea of having separate stacks for your different environments. And so the kind of, I guess the next evolution or a common pattern here is to say I'm going to have a separate project for each of my environments. So I have a test environment project, QA environment, and production environment. Each of these is its own project. And so this solves that blast radius problem because if you make your change to your test environment and you apply it, you're not going to break anything else. You have a higher level of confidence. You've constrained your blast radius to that one area. And this works quite well for a lot of teams and a lot of organizations. I think there are a couple of pitfalls that I've seen people run into with this. And that's mainly around keeping things consistent across these different code bases. So what can tend to happen is you start working on, I want to refactor the way this part of the infrastructure works, and so you spend time working on that, and then you have some smaller change that needs to go through quite quickly, and so it's okay, well, how do you do that? And what often happens is you end up skipping the kind of testing thing because that's in a bit of a state right now that you can't, you don't want to mess with it, it's too messy, and so you go and you make your change to production, and you may or may not copy that same change back to your other environments. And you get into the same situation you tend to be in with manually configured infrastructure of like things are not quite the same everywhere. And so in order to kind of do this effectively, you have to be quite rigorous, really. You have to be quite disciplined about how you make changes and how you keep things consistent. It helps if your team is fairly small, fairly mature, and everybody kind of communicates well and that sort of thing. You can pull this off. What I tend to recommend, or what I tend to use, especially with clients in some of the larger organizations where there's a lot more people and it's a lot more kind of churn, is more of I would call a template kind of thing, and this is moving towards the pipeline idea, right? This is the idea that you have one definition, so like this is what my environment looks like. Again, a couple of servers, load balancer, and so on. Here's the file for that, and I'm going to take the same definition and I'm going to apply it like to there, maybe pass in some parameters, and okay, that's my test, pass in a different parameter, it's my QA, it's my prod, and so on. And so that way you have consistency because you have a single kind of source of truth of what your infrastructure is. And so then the way you manage it is you move on to kind of pipelines for your infrastructure. So you're basically treating this the way you would an application. So you can do continuous integration on it. You can say when you commit a change to your infrastructure code, into the source control, then you're going to have something, and whether it's Jenkins or Go or Concourse or what have you, you're going to have something that's listening to that, detects the change, and then spins up or updates a test environment, runs some automated tests against it, and then says whether or not it's okay to use it then on further environments. And then you can build that out into a pipeline where your changes progress along. And again, this is like an application where you have, let's say you don't necessarily have your source code, different copy of your source code for each environment. You kind of like to turn it into an artifact, like a jar file or a WAR file or what have you, or an RPM or whatever, and version it and then pass it through your environments. And so the idea is that your infrastructure code becomes, you want to build it into, you can build it into an immutable artifact. Most of the tools out there don't really kind of support this way of working. It's something you kind of have to roll up your sleeves a bit and implement. But it does work quite well. And so one of the kind of key practices here is that your tool, your Terraform, your Ansible, whatever it is that you use to make changes to an environment is run by your agents and your pipeline. So you don't run it from your kind of workstation where you're going to check out code and make a change and then apply it to your test environment, your production environment, and so on. It's this way your kind of tooling kind of ensures the consistency. So why don't we do it from our laptop? So one is that our yours and my laptop might be different in some ways. We might have different versions of tools which might impact things that we don't expect. We also might clash, like I might check out the source code, make a change and apply it. You might make a different change and then we end up with different versions of the code being applied to an environment instance. And so we clash there. We might also be tempted to shortcut the process and not necessarily run all the tests. The pipeline kind of enforces the process. And particularly in larger organizations and more regulated environments like finance and so on, this becomes quite useful and quite powerful in that it provides an audit trail and a very kind of clear set of controls over how does a change progress through to production, who made a particular change. You have records of that. You have a kind of a really good kind of audit trail. And so when you're dealing with in an environment where you have people who are quite reluctant to get into kind of automation and DevOps and all that because they're worried that, we need a process where only certain people can make changes to each environment because that's how we guarantee that everything's right. Well, that doesn't actually work in practice, does it? Because people kind of do things manually. And even if you've got like this list of instructions of how to do it, people make mistakes or take shortcuts or whatever. Whereas when you have a pipeline and when you talk to these people, these auditors and change control, change management people about the idea that, we can have this pipeline and it's going to be it's going to implement the change control process in a very automated fashion. They really, really like it and it becomes a lot easier to kind of get all this stuff through. And when you can also kind of get them involved basically in like what kind of validations do you need? So what are the actual requirements for a change to go live? And can we put some automated checks that tell you that? Right, and so, but then you have the issue of, well, how do I deal with, we've got people who are working on the infrastructure code, right, and having to kind of have the pipeline, apply changes, how do we test, how do I write the code and make sure that it's working before I push it through? And so what we'll often do is this idea of like sandbox environments, and it's basically the idea that, okay, when I check out the code locally, I can run it against an instance that's just mine, right? So nobody else cares about it. If I break it, nobody cares because it's just me using it. And so I can, you can use that to kind of work on your changes and then, run tests against it before you commit it. So it's kind of just like application code. With the cloud, it tends to be, unlike with application, where you can run a local instance, you can't really run it on your laptop so much. You have to have, you tend to have the stuff running in the cloud. You're running Terraform, you got to kind of spin stuff up in the cloud to be able to see that it works. So that's kind of the approach there. One of the kind of pitfalls that we run into, so I'm working with a team at the moment and we're doing this, but one of the pitfalls we've run into is that people leave their sandbox environments running and then you end up with lots of these things running. So I go and make changes where I'm messing around with the cluster size to see what happens, how can I make really big clusters and all that. And then I go and talk at a conference and leave it running and everybody's kind of mad. And it's hard for them to destroy it because they don't have the same version of the code necessarily because it's checked out on my laptop, right? And so one of the things that we've started using for this is essentially have our own kind of pipeline stages where we can spin up a pipeline. We're using Concourse in this project. So we create a pipeline for Kief Sandbox. and then that's got my copy of the code in it. And then, when I go off and talk at a conference and somebody gets annoyed, I've got so many servers running, they can go and click the destroy button, and that's part of the pipeline is a destroy stage. And so it makes sure that it's using the same version of the code so that you don't get a clash and everything gets kind of hosed in the cloud. So then one of the questions is, okay, we're using this kind of artifact or this kind of copies of infrastructure code and passing along from one environment to the next, but we do have differences between those environments. We have to configure it. So we might have things like, so typically like there's the environment name you want to pass in, and then you use that when you're naming different resources in the cloud so that you can clearly see what's what, and maybe you tag things, and also to avoid clashes. If you have, obviously 2 instances of your stack have, say, a subnet with the same name, that's not going to work, so you have to give them different names. And so like the environment or something similar is often a way to kind of have something you can inject into your naming and so on to keep things distinct. And you might have other things like sizes. Maybe you want to have different sizes of server instances in different environments, or the size of your clusters, your minimum maximum sizes. Obviously in production you probably have a bigger size than you do in most of your test environments. So this is a mechanism to do that. There's a couple of approaches that I've seen or used to do this, and one, and this is kind of like the simplest in some ways, kind of like the most straightforward thing to do is just to have like files in your source control that are like named after your environments, and so each of these has variables that will get injected depending on the stage. And this works quite well, and it means that your configuration is version controlled and traceable and all those great things. So that's really useful. Some of the kind of things that can be painful, especially when you get that pipeline, is making a change to production. You're going to have to commit the change to your source control and push it through all of your pipeline stages. And that can take a while. When you're dealing with infrastructure, the pipelines can they might be a bit slow, and so it might be a bit longer than you would like in order to make a change to production. And it tends not to be valuable, right? Because you've only made a change to a configuration parameter that only affects the production environment. So all of those other pipeline stages are kind of like nulls, really. You're just running through the whole empty process of not actually testing a difference from the previous time you ran the pipeline, if you see what I mean. And so another pattern that I've often used is putting the parameters into the pipeline job definition. So if you're using like Jenkins or GoCD or something where you've got your pipeline configuration as code, and your stage that says, run Ansible, run Terraform, whatever, you can also put in here's the parameters to pass in when running it for this particular stage, this particular environment. And if you are using configuration as code for your pipeline tool, then that's in the version control, and that's all kind of nice and traceable and all those good things as well. So that can work pretty well. Another approach is to put them into a configuration registry. So in AWS, you can use something like the SSM parameter store. You might have something like Console or I don't know, Redis or what have you. And so you have like conventions around here's where the variable names live, and you pass in maybe just the environment name, and then it uses that to go and look up which things are applicable to that particular environment. So those are a couple of patterns I've seen. I guess the overall recommendation I would say is to minimize what you actually configure, right? If it gets out of hand, and you've got all these kind of different variables that you're passing in and having to kind of manage between environments, obviously that's more room for error, right? And it's more room for variations between environments that kind of make your testing a little bit less valid. It's because you're testing it in a QA environment, you've configured it a certain way, and then in production you've configured it, with different options. And so things might go wrong that you would have caught with tests if they'd been more consistent. So as a rule of thumb, it's just like try to kind of make things as consistent as possible, even with your applications from one environment to the next. All right. So now I'll talk a little bit about testing of infrastructure, which is always an interesting topic. How many people here do automated testing of infrastructure? That's a question. I see like 4 maybe hands, a few half hands. So it's challenging, right? And I think there's a lack of maturity in the tooling, I think, as compared to some other things. So Chef and Puppet in particular have very mature ecosystems for testing tools, unit testing at that level. I think Ansible has a fair bit as well, but like Terraform it's much less, and things at that level certainly it's much less. So you tend to have to kind of cobble together your kind of testing tools. And it's something because it is one of those things where it's just kind of like a maturity in the industry, I guess. The more and more it happens, the more people see it and get experience with it, the more common it will be, right? It's kind of a snowballing thing that I think hasn't really come out there yet. But an important thing, I guess an important point that I find with testing. So my background mostly, before I joined ThoughtWorks, I didn't really do kind of TDD and that stuff very much. It was always one of those things I would try it a little bit, get enthusiastic, okay, I'm going to do, I'm going to get JUnit or whatever the thing is. I'll do it a bit, and it's kind of slow and painful, and then I kind of like abandon it because I have to get work done, right? But one of the things I've found in working with teams where they use it as a habit is like it's like any habit. It's like exercise, right? Once you kind of when you don't do it often and then you do it, it's like really painful, and you're like, oh, next day you're like, I'm never going to do it again. But if you get into the habit of it, it becomes something that you kind of can't live without, right? It's kind of hard not to do it. And one of the things I found with infrastructure in particular with the testing is that it helps you to keep your design clean. So I'm going to talk a bit in a little bit about like patterns of kind of splitting up infrastructure, but one of the key points is that this automated testing forces you to keep things kind of nicely decoupled and all that, because you can't write automated tests for a big ball of mud. An automated test, in order to like test this one thing on its own, it has to have kind of clean interfaces and separation from the other things, and so it helps to drive good design. So it's as much a design tool as a testing tool, really. So I'm going to kind of whip through an example of a pipeline and kind of testing different elements of an infrastructure. And this is kind of the example infrastructure. So the idea is that these are like subnets on an AWS kind of system. We've got a load balancer up there in public subnets, auto scaling group, and with servers that run on the private subnets. So that's the infrastructure stack in the orange. And we've got our application servers, and on those we've installed a JDK, Tomcat, and then our application war file we kind of gets deployed into those servers. So that's what we're kind of trying to build. And so the pipeline overall is like this, right? And I'll go through this piece by piece. So first of all, we have our application. Let's say it's a Java application that we build into a war file and deploy on Tomcat, pretty standard stuff. So this looks like for any Java application pipeline. So you have your kind of continuous integration build stage that runs unit tests, then creates the war file, and then we have a stage where it actually deploys and runs the war file. Also, this same works in like the Docker world. So you might be packaging your application up into a Docker image, and then running that and testing it, not within the context of the cluster, right? Because you're trying to get fast feedback. Does my application, the functionality, the Java code that we wrote, does it work right? Does it work right inside the Docker container before we want to have to spin up a whole infrastructure or deploy it onto an infrastructure? So fast feedback there. And then for our kind of server configuration, and again, the patterns apply to, so we've done this, actually in my current project, we're using ECS clusters rather than Kubernetes, but we're using Docker and clusters. And the idea is that we're testing different elements of the stack. But in this example is a little bit old school. So we're using virtual machines. And so we've got a chef cookbook that installs Java onto it and then installs Tomcat. And it creates this kind of generic app server role. So we might use this for other applications, for multiple applications, the same role, right? This is a chef role that says, here's the cookbooks to pull in. And so then we can apply this. And we can use tools like Test Kitchen and so on. And often, for this level of testing, I found it useful to use Docker as like a testing environment. You're going to have like just the minimal operating system and just the things that we want to test, apply the chef to it. And then see, does it hang together and do what we expect it to do, some simple kind of tests there. And then we might build an AMI based on this, right? This is AMI building. We use something like Packer. Something like Packer. I don't know anything else that really does quite what Packer does. But it's a long process, right? Because it involves spinning up a whole server, applying your cookbooks or what have you to it, and then you kind of take a snapshot of it. And ideally to test it, then you want to spin up a new server instance from the AMI to show how does that server instance look and run tests against it. And that's a pretty long, slow process. And so this is why we do the testing of just the cookbooks and the role on their own in a Docker container before we go through building the AMI, because we don't want to spend all this time on something we could catch earlier in the pipeline, catch much faster. Right, so now we've got the AMI. And now we've got our infrastructure stack. And so this is where we take our kind of Terraform code, and we might have depending on how our infrastructure looks and what's in there, we might say we're going to test just like the kind of the subnets and the routing and that kind of stuff that happens before we actually deploy a server into it, an application server, again to get faster feedback. And so we might do something like spin up a little test server instance here and there, and then can they connect to each other? So different strategies you can use to kind of test. It depends on what it is you're kind of, what risks you're trying to address. What are the things that typically break in your infrastructure, and what's the earliest point you could do something to test that and catch it before having to kind of go full blown. And so the way we often do this kind of stuff is the infrastructure, because this is where you actually have to use the cloud. It's hard to test. Terraform and most of these tools tend not to have very much that you can do, like unit testing, as in something where you're going to take the code that you've got and test it without actually creating infrastructure out on the cloud. You can do like syntax validation and linting and a few things, but it's hard to test very thoroughly at that level. So you kind of have to spin up an infrastructure, actual stuff in the cloud, and then run tests against it. And there's tests like AWSpec, InSpec is one that the Chef folks have come out with, which is a bit new, but it's very well kind of designed. And so it's what I'm kind of using these days. It's based on RSpec, the Ruby kind of testing framework. And but there's obviously equivalent tools in the kind of Python space and so on and so on. And so the idea, what I typically will do here is spin up a whole new clean stack, run the tests, and then if it passes, they tear it down. That's a little bit time consuming, but again, we're kind of using a minimal infrastructure here. It's when we get into kind of integrating the stuff together. So this kind of test all stage here is where we put all the pieces together and say, we're going to spin up our infrastructure with those AMIs and deploy our WAR files onto it. And then test the whole thing runs. And this is where we might do like journey testing, might have like, I don't know, Selenium or Cucumber or something that kind of interacts with the application and says, does it all hang together? Is it talking to the database? Does all the things work? And that tends to be quite long. So what we'll often do here as an optimization is this is where we'll have a kind of a more persistent environment. And this is a trade-off, right? So I'm uncomfortable with this because there's two different things, I guess, situations you kind of want to be testing here. One is, so it's fine, I've got my environment I've created, and now I'm going to, with the previous version, now I'm going to apply changes to it, and that's faster because you're just applying changes rather than creating a whole new set of infrastructure. So that's faster, which gives you the feedback that you want in time. But also, like, environments that live for a while can kind of have things go wrong, things accumulate cruft, or people go and like make changes to it because like, oh, the deployment didn't work, I'm going to go and just poke it a little bit to get the test to pass, and then kind of that doesn't get kind of captured back in your scripts and so on. And so I quite like destroying everything and bringing it up again from scratch and then testing it and making sure it all hangs together. But on the flip side, you do need to test whatever it is that you're doing in production. So you may have the kind of infrastructure, kind of system design, where you can kind of do that immutable thing, or blue-green, rolling deployments, canary, whatever it is, to where your production deployment means you're creating a whole new thing, or a new thing, and from scratch, and then swapping it around or what have you. But if not, then you kind of want to be testing somewhere in this process. You want to be testing whatever it is you're actually going to do in production for your kind of release process to make sure that that's well-oiled and you catch things before you actually go to production. So that's kind of whipped through on the testing stuff. Some overall recommendations, and a lot of these are kind of generic to all of kind of software development, test-driven development. So people who write the codes really should write the tests because that's the best way to keep them in line, and also to make sure that the tests do inform how the architecture works. Again, keeping things decoupled and all of that. You get the strongest benefits if people are responsible for both sides of those. Or at the very least, if you have some more kind of sophisticated automating testing, or the end-to-end stuff, that you have your testers, specialists working closely with the team, as opposed to being like people write a bunch of code and then throw it over the wall at the testers, and then the testers try to get it tested in time, and bosses say you have to release anyways, even if they haven't finished testing, because we've got to go live, right? We'll fix it later, and then we don't. Right, and so with infrastructure in particular, there's what we call reflexive testing, is this thing of like, so you've got like say a Puppet manifest, and it's going to install Tomcat, and then you have a test and it says, was Tomcat installed? And it's like, well, what are you really testing there, right? You're testing that Puppet works, you're testing that I don't know, whatever the installation command, package installation command works, and doesn't return an error if it doesn't, right? Because it's like, so you have to think about what are the failure conditions you're looking for, and the failure condition of a test that my package is installed is that, well, I ran the package install command and it didn't install the package and it didn't return an error code. And that's pretty unusual edge case. So, and you can end up with like a lot of tests, like testing really trivial stuff. Okay, we created this file. Is that file there? Yes. When you've got like a definition, and code, which are just the same thing. It becomes kind of an exercise in like almost bookkeeping. Oh yes, we changed this code, so we have to change that code to match, and rather than value. You need to think about what the risks, like what is likely to go wrong. For me, it's like what confuses me in the code that I'm writing. Right? I'm writing code, and it's like, is this thing going to work? Is this right? That's where I want to have a test to tell me, did it do what I thought it was going to do? Where I'm puzzled about that or confused about that, that's where I want to test, or that's where I want to simplify my code so that it's easier to understand even better. Yeah, and contracts are important. So as we get into kind of like things that integrate with one another, you want to have tests that kind of just confirm that I haven't like broken an API or a contract or something that some other bit of code somewhere else is relying on, which is where we get into this stuff. So monolithic stack. So this is where your application, your system gets bigger and bigger and bigger. And you've got all the kind of stuff in it. So your environment is all of this, right? And all these different teams using it. And it's one big Terraform kind of project. Maybe you've broken it up into modules, but that kind of doesn't help the fact that you've got a single kind of state file sitting behind this. And somebody who makes a change up here might accidentally break something that team relies on. So again, it comes down to blast radius. And so the goal here is to divide your infrastructure into kind of different stacks. And so it's kind of that monolith to microservices thing, although it's, it's all kind of down to I guess your particular situation, your architecture, your system as to like how far down you want to break things into what's the appropriate level. But the point here is that each of these stacks can be changed on their own, and the integration points are made clear, right? So each of these stacks should have its own pipeline that delivers the changes. And then the tests, and this gets into where the tests help with keeping the design clean. So we've got our one stack, and maybe this is our, my application or my service stack, and it's got an application server, database schema associated with it, and the networking just for that one service. And then I can have a pipeline and test, which is test that in isolation. And even though I might rely on other services or other things might rely on me, I want to be able to kind of deploy and test this thing on its own in isolation, so I can make sure that the thing that I am in control of and I have power over works as I expected before I then try to take it and integrate it with other people's stuff and see does it work in that context. And so for integrating infrastructure stacks, when you've got these, so what are the kind of mechanics of that? And patterns around that. So in an example here, we've got a common thing of where we have a shared infrastructure stack. So this might declare a VPC and some subnets, and then each application might have its own, this is where it has like the servers and networking rules related to that application in particular, right? So we've kind of broken this apart. And the one stack that creates the VPC and subnets, that exports some variables that this stack needs to then import to use to know, how to kind of deploy its infrastructure into it. And so one pattern for doing this is integrating it at apply time. And this is the idea that you run your tool, and it creates the VPC stack, and then reads the variables that come out of that, and then passes those in as it creates the the application stack. And the problem with this is, so it puts the logic into kind of whatever scripting you're using to run your tool. So people who use Terraform and these kind of tools tend to use like make files or shell scripts or whatever to kind of like orchestrate running these things. And if you're doing your integration between your different parts of infrastructure at this point, it just kind of becomes monolithic. The deployment becomes monolithic. You have to kind of like run the deployment for all your stuff as one kind of process that knows about everything, and that becomes kind of a bottleneck. So another way to do it is kind of by resource discovery. So it's like, okay, when I deploy my applications infrastructure and I need a subnet to deploy it into, I can kind of do a lookup. And like Terraform supports this, and all these tools kind of support this idea of go and look for subnets that are named this way or that have these tags on them, and that's how I know it's the subnet for my environment and that is the one I'm meant to use. And then you can kind of bring that in. And so that works fairly well. It's kind of coupling at that level, really. Another thing is to use a configuration registry, and that kind of like decouples a little bit more and says, okay, I don't necessarily need to know about how somebody else's infrastructure was created, but we have a contract which says when I create subnets, I put the kind of information about those into a configuration registry, under certain, a certain path, so that you can go and look that up and use it in your applications infrastructure to put your applications into. And then a fourth one, and this is one I don't recommend, is integration by remote state, which is common in Terraform. How many people are familiar with this? A couple. Okay, so this is actually, it's like HashiCorp kind of recommended it. It's kind of like the standard way that people do things, and a lot of their examples have it. And the idea is that, so when you create, so Terraform has this concept of state. When you create your stack, you've got a state file that lives somewhere, and there's various ways of putting it into a kind of shared location or what have you. And you can have your other stack go and look up that state file and find the kind of parameter values, so it can find things like subnet IDs from that, and then go and use those, which works. But it's coupling at the level of that state file, which is essentially the internal data structure that the tool uses. And so it means that sorry, I'm getting really dry here. It means that if you change the version of Terraform and it happens to change the structure of the state file, which does happen, that means you've got to upgrade kind of Terraform across all of your different things, and that can become big if you've got a big project. So we had this, we got bitten by this, where there was an upgrade and it changed, and we couldn't. It was like we had to take a week off, basically, to kind of plan and carry out the upgrade of Terraform across all of our pieces, because otherwise it would break. To me, this is like integrating applications at the database schema level. It means you're kind of really tightly coupled down at that level. So I much prefer the previous approaches that I suggested around it. At the very least, kind of looking up the tagging and so on inside your inside things. So some overall it's like a little bit grab bag of recommendations around this integration of stacks. So one is those integration points between your stacks, whatever mechanism you use, they are contracts. And so you need to treat them that way. You need to follow the practice of API design. So the idea, things like you shouldn't kind of, change an integration point. If you want to make a change to something, make a new thing and expose that, and then let other kind of people move over to using that, and then when they're all done, you can remove the old one, deprecate it, that kind of thing. Again, it depends on the size of your team and the number of teams and how closely coordinated you are. But at the end of the day, it's a contract. It is useful to use kind of fitness function or automated tests, again, to ensure the integrity of the contracts. If everybody's expecting your subnets to be tagged in a certain way, have some tests that run and tell you, oh wait, you've changed that tag, that's going to break something. And so you need to think about that. And again, as I've said a couple of times, all this stuff will help maintain those boundaries between your stack and keep them from being too tightly coupled. And that's pretty much what I've got. How much time do we have left? Is there any? Sorry.
Actually, 2 minutes.
2 minutes. Okay. All right. Well, thanks. Yeah.